Hello and welcome to Research Tuesday. I'm your host, Dr. Richard Harris, and this is a 5-minute-ish hot take on some current-ish research. And today we're going to be talking about one of our favorite molecules, and that's coenzyme Q10, also known as CoQ10. And CoQ10 is well known in circles mainly because of the drug statins, like Lipitor, because they deplete coenzyme Q10. But a lot of people don't know what coenzyme Q10 actually does. So within our mitochondria, our powerhouses of our cell, coenzyme Q10 does a couple of different things. Number one, in two parts of those mitochondria, it helps with energy generation. It's what we call the electron transport chain. This is how we turn food into energy using oxygen. So if you don't have enough coenzyme Q10, you're not going to make as much energy. Now the process is a lot more complicated than that, but we're just going to leave it as that. Well, coenzyme Q10 is also involved in the metabolism of certain parts of our DNA. So we're not going to make DNA, the certain part of our DNA, if we do not have coenzyme Q10 on board. It's also involved in the metabolism of fatty acids. And then there's also some other mitochondrial proteins that coenzyme Q10 is necessary for. It also helps with regulation of how we get certain nutrients in the mitochondria, how permeable they are. So that's another function of coenzyme Q10. And why you're seeing it used a lot, in addition to its function in generating energy in the mitochondria, is it's an important fat-soluble antioxidant. And so we all know that antioxidants are beneficial. We mainly get these from nutrition, fruits and vegetables, but certain people can have issues where they don't have enough antioxidants on board. Statins are one of them. There are genetic abnormalities that can be involved with abnormal CoQ10, and they could be in the genes that make CoQ10 or in a gene called NQ1. And the company that I'm on the advisory board of, Routine, it actually looks at this NQ1 gene mutation because that determines how much of the active form of CoQ10 you can actually make. So there's an active form and an inactive form. When that CoQ10 is used up as an antioxidant, it becomes that inactive form. And so that NQ1 gene looks at that and says, okay, can we take that inactive form and make it back active? Now, while we're talking about antioxidants, CoQ10 also helps with the regeneration of other antioxidants, vitamin C and vitamin E. These are two very popular antioxidants. But if you don't have enough CoQ10, then you're not going to be able to regenerate these antioxidants. CoQ10 also has been shown to decrease inflammatory markers and inflammatory mediators. It also has a role in cholesterol metabolism. We're about to launch our podcast tomorrow on cholesterol and how we've gotten cholesterol wrong and mainstream medicine has gotten cholesterol wrong and what to actually do about your cholesterol. CoQ10 has a bunch of other different things it does in the body as well. It affects the expression of a number of genes. It's involved with the synthesis of a couple of amino acids, glycine, proline, and arginine. And so you can see that there's a lot of important things that CoQ10 is used for. So the daily requirement is not known. It's estimated that we use about 500 milligrams a day. You can only get a small amount from diet, about 5 milligrams a day. So most of this is synthesized inside the body, and it's particularly found in highly active tissue. Well, the most active tissue outside of our brain is our kidneys, our hearts, our skeletal muscle, and our liver. And so it can be synthesized in all tissues, but most of it is produced in the liver. Now, a really interesting thing about CoQ10 is it can be depleted by medications like statins, but it also goes down with age. So production at age 65 is approximately 50% of age 25. And so that's why you can see CoQ10 deficiencies as we get older. Now, CoQ10 deficiencies are associated with a number of mitochondrial diseases, but they're also associated with cardiovascular disease, kidney disease, diabetes, and metabolic syndrome. CoQ10 deficiency can also be caused by vitamin B6 deficiency. As we talk about in holistic medicine, all these things are connected. So vitamin B6 is necessary for the synthesis of CoQ10. Certain other drugs like amitriptyline can decrease CoQ10 as well. So these are some things I may look at when I'm working with clients. Now, what are some of these clinical consequences of CoQ10? Again, like I said, if they're mainly involved with liver, kidney, and metabolism, we've seen it in myopathies, muscular diseases, cardiovascular disease, diabetes, kidney disease, liver disease, and even critical illness, mainly probably because you're using a lot of these antioxidants when you're in a critical illness state. What a lot of people don't realize, and we're talking about this tomorrow on the podcast, is that LDL is not this boogeyman. We'll talk about why, but a major reason why statins can deplete CoQ10 is that you reduce the amount of LDL, but LDL is a carrier for a lot of these fat-soluble vitamins and antioxidants. So that can lead to deficiencies. So how much do we supplement? Usually for certain conditions, it's about 100 to 300 milligrams broken up between the day. There was one study that looked at heart failure. They were given 100 milligrams 3 times a day. And supplementation with CoQ10 reduced the risk of cardiac-related deaths by 43%, all-cause mortality by 42%. In another study, there was a group of cardiac patients, and major adverse cardiovascular events were reduced by 67%, cardiac-related mortality by 53%, all-cause mortality by 55%, and it actually improved the ability of the contractility of the heart by 6%. That's a major difference. Another study looked at chronic kidney disease. They supplemented 200 milligrams a day for 3 months. Diabetes. Diabetes, 200 milligrams a day for 3 months. Saw a significant reduction in A1C and plasma glucose levels. The CKD study used 100 milligrams a day, 3 times a day. And there was a significant improvement in renal markers for kidney function, which is really interesting. And in this study, also the dialysis requirements for patients went down. And then another study looked at CoQ10 with non-alcoholic fatty liver disease. This is basically where the liver gets infiltrated with fat. And there was a decrease in inflammation, liver inflammation with CoQ10. And they also showed a decreased markers of oxidative stress as well and inflammation. And that was 100 milligrams a day for 4 weeks. So these are just a review of some of the studies that have shown benefit with CoQ10. Like I mentioned, it's something that we look at when we do our gene analysis with routine. There will be a link in the show notes and in the YouTube, also on all the other platforms where you can check out this service routine. I love it for my clients because it does look at these gene analysis. It also looks at 50 plus different genes, 80 plus different metabolites and nutrients. So you can create a personalized supplement package in an easy and convenient way to take. And it's cheaper than the way I was doing before. I'm just being honest with that. I'm always trying to do the best I can with the most cost-efficient method. So I know we went over 5 minutes. This one was a little longer, about 10 minutes, but there's a lot of great information in there about CoQ10 in this review. So please leave your comments. I'd love to hear from you if you want to hear anything specific. If you have a study that you'd like our opinion on, just let me know. Otherwise, we'll be back on Research Thursday with another article. Thank you and God bless.